Okay, let's talk about the other branch of predictive analytics, and the last one on our infographic, machine learning. So, in what situation is it preferable to make predictions using machine learning rather than traditional statistical methods? You can find a detailed explanation of machine learning in our machine learning course. In this video, we will provide you with an example showing what ML is all about. Great, let's begin. What is at the core of machine learning? Creating an algorithm which a computer then uses to find a model that fits the data as best as possible and makes very accurate predictions based on that. And how is that different from conventional methods? Well, we don't give the machine instructions on how to find that model. We provide it with algorithms which give the machine directions on how to learn on its own. So, how can we describe a machine learning algorithm in a few words? A machine learning algorithm is like a trial and error process, but the special thing about it is that each consecutive trial is at least as good as the previous one. Technically speaking, there are 4 ingredients: data, model, objective function, and optimization algorithm. Let's illustrate them with a fictional example. Imagine a robot holding a bow. We want to find the best way to use that bow to fire accurately. In other words, the usage of the bow is our model. The best way to learn archery is to train, right? We train by taking different arrows and trying to hit the target. So, the quiver of arrows will be your data, or more precisely, the data that the robot will use for training. They are all arrows, but they have their subtleties. There are straight ones, crooked ones, light ones, heavy ones. So, we can safely say the arrows represent different data values. Okay. We said the robot will be firing at a target, right? Well, in machine learning, or at least in the most common type, supervised learning, we know what we are aiming for, and we call it, that's right, a target. Here comes the third ingredient, the objective function. The objective function will calculate how far from the target the robot's shots were on average. Here comes the fourth ingredient, the optimization algorithm. It steps on the findings of the objective function and consists of the mechanics that will improve the robot's archery skills somehow. Its posture, the way it holds the bow, how strong it pulls the bowstring, etc. Then, the robot will take the exact same data, or arrows, and fire them once again with its adjusted posture. This time, the shots will be, on average, closer to the center of the target. Normally, the improvement will be almost unnoticeable. This entire process could happen hundreds or thousands of times until the robot finds the optimal way to fire this set of arrows and hit the center every single time. Okay, the machine learning concept in this example is clear. Nevertheless, it is important to remember that while training, you won't provide the robot with a set of rules. That is, you won't have programmed a set of instructions like place the arrow in the middle of the bow, pull the bowstring, and so on. Instead, you will have given the machine a final goal: place the arrow in the center of the target. So, you won't care if it places the arrow in the middle or in the bottom of the bow, so long as it hits the target. Awesome! Another important thing is that it won't learn to shoot well right away. But after 100,000 tries, it may have learned how to be the best archer out there. Anyway, now you might be asking yourself, aren't there infinite possibilities to trial? When will the robot stop training? First, interestingly, the robot will learn certain things on the way and will take them into consideration for the next shots it fires. For instance, if it learns that it must look towards the target, it will stop firing in the opposite direction. That's the purpose of the optimization algorithm. Second, it can't fire arrows forever. However, hitting the center 9 out of 10 times may be good enough. So, we can choose to stop it after it reaches a certain level of accuracy or fires a certain number of arrows. Nice. So, let's follow the 4 ingredients. At the end of the training, our robot or model is already trained on this data with this set of arrows. Most shots hit the center, so the error or the objective function is quite low or minimized, as we like to say. The posture, the technique, and all other factors cannot be improved, so the optimization algorithm has done its best to improve the shooting ability of the machine. Great! We own a robot that is an amazing archer. So, what can you do? Give it a different bag of arrows. If it had seen most types of arrows while training, it will do great with the new ones. However, if we give it half an arrow, or a longer arrow than it has seen, it won't know what to do with it. In all ordinary cases, though, we would expect the robot to hit the center or at least get very close. The benefit of using machine learning is that the robot can learn to fire more effectively than a human. It might even discover that we've been holding bows in a wrong way for centuries. To conclude, we must say that machine learning is not about robots. What people use it for is to improve complex computational models that can find infinite applications in our daily lives, especially in the business world. And the complex computational models we are talking about step on the fundaments of regressions and cluster analyses models we discussed in our previous videos, and take them to unconventional but extremely useful levels. After we discuss the 3 major types of machine learning, we will provide 2 examples of real-world applications of machine learning. Catch you later!